Hello students, we are still adding vectors using the parallelogram rule. Here we have two vectors. Vector A, this one is 9 centimeters at 15 degrees, and vector B is 8 centimeters at 50 degrees. So what is the vector sum of the two? We are looking for the vector sum of the two. So what is the vector sum of vector A and vector B? We usually put these arrows to show that they are vectors. They have magnitude and direction, magnitude and direction. All right, remember the first thing to do is to draw the x, y axis. So let's draw the x-axis. That is should be horizontal. Try to make it horizontal. I try to look at the ruler properly, make sure that it's horizontal. So that's this is my x-axis, and my y-axis, I draw it this way, making sure that it is indeed perpendicular to the x-axis. So that's my y-axis. It's always nice to position our vectors in the x and y axis. We're going to start drawing our vectors. The first vector is 9 centimeters at 15 degrees, at 15 degrees. So the first thing to do is to get the angle right. So let's get the angle. So I'll take the center. Sorry, where is it? The center of the protractor. If you can see, the protractor is so transparent. I don't know if you can see it. Maybe here. The center of the protractor must be lined up with the origin like this, and the 0 degree line must be lined up with the x-axis. The x-axis is there. Okay, like this. All right. So it's very important to line up the center or the center here and line up with the x-axis. So it's lined up before you start counting. Then you start counting 10, 20, it's 15. So 15 is somewhere there between 10 and 20, 15.0. So somewhere there. And then I will draw a line that is the 9 centimeters. 9 centimeters there. Okay, 9 centimeters is this one. That's my 9 centimeters. And the angle is 15 degrees. The other vector, if you remember, has to be this one. 8 centimeters at 50 degrees. So let's deal with the angle first. Position my protractor. The center has to be at the origin, and line up the 0 degree line, line up with the x-axis, and then go ahead and count 50 degrees. 50 is there. 50 is over there. Then that line must be 8 centimeters. 8 centimeters. So go ahead and get your 8 centimeters there. 8 centimeters. So if I draw the line, I see that 8 centimeters is there. There, exactly there. So that's my 8 centimeters, and the whole of this angle from this axis, it's 50 degrees. I don't know if you can see that. That's 50 degrees. 50 degrees. Okay. All right. And then we have to transfer this 8 centimeters vector, transfer it parallel to itself. That's the issue. We have to make a parallelogram. So we transfer until it is there, But where? Should it be like this, like this, like this, like this, like this? You don't know. It has to be somewhere there, right? So for that to happen, we need to draw a new origin here, a new origin. So the new origin will have its new x-axis that will be parallel. So I'll put my ruler like this. So this is what I do. I line up my ruler like this, see? And then I push the ruler. Making sure that it's aligned up with the x-axis all the way until I get the dot here. See, so what I'm trying to do here is to form a new origin with new x-axis. So something like that. This one, like that. So it looks like, let me see. It has to be parallel. Okay, so we are trying to make it parallel. Okay. All right, so we are going to have a new origin along this line. So that's your new x, and the perpendicular line has to also be drawn, because I mean, once I know that this is my new origin, this line is parallel to the x-axis, then I can draw my other angle. Okay, remember this line is parallel to this x-axis, so that I can draw my angle right there. So this will be new origin here, and I'll position my protractor here, and it will be lined up with the new lined up with this one. This will be new axis. Okay, there. And then I can count to 50. All the way 50 is right there. 50 is right there. Okay, from the new axis. 50 is right there. Okay, then you draw your 8 centimeters. So 8 centimeters can be drawn now. You're transferring it to there. So 8 centimeters will be here. It'll be 8 centimeters. 8. Oh, these are inches. I have to be careful. These ones centimeters. That's why it's good to use a pencil. You make a mistake. So these ones are dotted lines all the way to 8 centimeters. Okay. Yep. Once you have that, you know that now I have this angle as 50 degrees. And remember, this line is the new x-axis. Because it's the same as this one, x-axis. Okay, so it's the new x-axis, this one. Okay, and then you have your parallelogram. You can now connect this point and this point can be joined. Connect those points. Okay, there. Again, I keep on forgetting, this has to be dotted line. Okay, so you have your parallelogram, and finally, to find the resultant, you draw the diagonal. The diagonal, you know how to draw it from corner to corner. Diagonal is here. That's your resultant. Let's measure it and see how long it is. Let's measure it. If I try to measure it using the centimeter line, I'm going to have how much is this? It looks like 16.5. Yeah, it looks like 16.6 centimeters, and the angle from the x-axis will be The angle looks like it's 30 degrees. I see that the angle is about, looks like 31. It's 31 degrees. So this angle here, the angle of the new vector is 31 degrees. So resultant, let's finalize this, let's summarize this. So we have done everything and we have found that the resultant is 16.6 centimeters at an angle of 31 degrees from x-axis, counterclockwise. All right, so that's what we see there. Now let's check using our online calculator to see if indeed the result of adding 9 centimeters at 15 degrees and 8 centimeters at 50 degrees, if the result is indeed equal to 16.6 at 31 degrees. So we can check that using our online calculator. So let me try to share that here, our online calculator. Okay, I'm sure you're able to see the screen. I hope you're able to see the screen. Okay, let's see. Okay, these are the odd values. So the new value is 9 centimeters at 15, and 8 centimeter at 50. These are the new numbers. And then I calculate again here. So I got 16.2 and 31.43. Not bad. Very close to what I found before. Very, very close. Very, very close. So what was the angle again? That was 50. Yeah, 50. Okay. Yep. So the results are close. And that's the procedure for finding the resultant vector whenever you have vectors in the first quadrant. All right. Okay, so we are going to practice more. We are going to try to put vectors in the second quadrant, third quadrant, fourth quadrant. So in other ways, let me just maybe show you something about the quadrant. So later on, we are going to, let's see if we have space here. Later on, we are going to see if we can have our x axis here, y here, if we can have a vector here, okay? If we can have two vectors here and see if we can solve the problem. Or maybe if our vectors maybe are lying in this region, maybe two vectors, if we can do the same here or like that, okay? So we'd like to try to see if we can do something else. If this example, the vectors were here, but next the vectors can be here, or they can be here, or they can be here, right? So this is the first quadrant, second quadrant, fourth quadrant, third quadrant, fourth quadrant here. All right, so that will be next, but for now, that's it.